Okay, now I want to talk about the two-dimensional range tree, on building the two-dimensional range tree and how it happens. So build two-dimensional range tree. The idea would be like this. We will have the main tree, which will base on the first axis that I use. For example, if we are in two dimension and we have x and y dimension for each point, so the first tree will be based on the x-axis, and it will be binary search tree based on the x-axis. I mean, I will have the root and then points and then points, and it will be based on the binary search tree idea. So here it's what is below, for the left it was below or equal, and to the right is what is higher in value, or let's call it below. Maybe the better name is lower value or equal. Okay, it's in binary search tree, but it's based on the x-axis. Mainly I build the tree based on the values on the x-axis. Now for each node in that tree, for example, take this node, I will have an associated, let's call it J associated, a binary search tree that will be based on the y-axis. For example, for this node, I will take all this subtree and we'll look at the y-axis of these points, and we'll build again a binary search tree based on that point and all the subtree, let's call it P of, I don't know, V, if this is V. So this is V and this is, all these points are the P of V, as P will be named for set of points. Let's call P set of points. Okay, so for each node I will have this associated tree, binary search tree. This will be for each node. For this one will be as well a y-axis binary search tree based on his subset of points. So let's maybe start with an example. Let's take some points. For example, I don't know, 1, 2, maybe 3 to 7, maybe, I don't know, 2 to the 6, maybe 7 to 1, and maybe another one, it would be 8, 3. Okay, so this set is the set of points. Let's call this set P. Okay, this is the set of points. Now what will I do? I will start to build the main, let's call it the x-axis tree. Now note that I'm talking about the two-dimensional tree. This is why I'm using the x-axis first and then the y-axis, but I can take it for higher dimension, and then for each node here, for example, I will be a z-axis binary search tree that is related, and again another tree, and I can take it into another dimension, I don't know, to any higher dimension that I want, and will be associated trees in correlation to the number of dimension I take. But now we will be focused on the two-dimensional case, and we will assume that we start with the x-axis and the associated tree will be with the y-axis. It's arbitrary, but for the organization I will do it like this. Okay, so what do? I start with looking at the x-axis of the points, and let's find the one in the middle. So I have 1, 3, 2, 7, 8. Which one is on the middle? Let's look. 1 and then 2 and then 3 and then 7 and then 8, for example. Of course 3 is the x mid, and I will build my tree based on it. So this will be my, let's call it root. So I will have here 3, this is with the first node, and of course again I will have j's associated. J associated, which will be based on the y-axis. So what I will do, I will build now a binary search tree based on the y-axis. So here I will take the y-axis of the points and start to build a tree. So let's look at how it looks. So let's look at the y-axis points. Let's organize it. We have 2, 7, right? 6, 1, 3. So I have 1, 2, 3, 6, 7. 1, 2, 3, 6, 7. Okay, and now let's build a binary search tree. Again, it happened. Oh, I don't like it that it happened. Maybe we'll do something else. Let's take here now another point, another value, so you won't get confused with the 3. So let's take 4. So you won't think that this one, what I do here. So here I take the 4, which is the middle, and I start to do a binary search tree. So here I will have a 2, and then I will have 1, and then I will have 6, and then I will have 7. What an awful looking binary search tree. Maybe I'll do something more beautiful somehow. I don't know. Okay, so it's not very beautiful and I don't really like it. So maybe instead of 6, let's take 8. And then what I will have is this one. We'll have 8 and 7 will go to the left, and it will a little bit look like better, like, I don't know, 6. Okay, maybe a little bit. And let's take, no, I don't want another point. Okay, so let's take it like this. Maybe instead of 1, let's put 9, and then it will look much better. Let's put 9. Let's put 9 here. Okay, now it looks a little bit more balanced and organized. Okay, so let's make the changes. So we have the points 2, 4. Oh, I will get another one for the middle. Oh, that's not good. Let's go back. Let's put it like this, and that's it. Let's do your 8, and then 7, and it will stay like this. Okay, and this is the associated y-axis tree associated with the first node in the x-axis, the root node, and great. This is the binary search tree based on y-axis, and this is the x-axis tree. And this one I will continue building. So here I'll go to the left and to the right. Now, what is less or equal? All the points that are less or equal will go to the left, and the other will go to the right. So let's take this and continue. And now we have here in the left side the 2, the tree with 1 and 2, and to the right side I will have the tree with 7 and 8. Okay, now I will build the associated trees of each based on associated J associated based on, again, the y-axis here and the y-axis here of these points, but will based on the value of the y-axis. So I will have, let's look at the points. So we have 1, 2, and 2, 8. So here I have the points 1, 2, and 2, 8, and here I have the points 7, 1, and 8, 4, 7, 1, and 8, 4. And now for each one I will look and build a binary search tree. So it will be quite straightforward. And this is 4, and here it will be again straightforward 2 and 8. Okay, and here I take the middle. I don't know, middle, let's choose someone, this one, and let's take this one. Oh, maybe let's take this one. Okay, great. Now I will take to the right here, let's just define something. This is the P I have here, which is 7 and 8, the points of the which contains 7 and 8, and I chose 7, and here I have 1 and 2, which I chose 1. Now what can be chosen the next? Of course I can only choose 8, and here I can only choose, I have left only with 2. Okay, so for each one it has an associated y. So here in that group I have only 1 point, which are the point that are related to this one and that one. So binary search tree associated with this is only 4, and the binary search tree associated with that is only 8. Okay, and that's it. I got to the leaves, and if I get to a leaf, there is okay, and that's the idea. Now let's look at the algorithm of Build2DRangeTree, and let's go on the pseudocode, and I wish we will understand how it works. So what the function gets is the set of points, which we will call P. Okay, so what I input a set of points, P set of points in the plane, and what I output is the root of the tree. So the root of the tree. Great. Now what I start with is by constructing the associated binary search tree. Build associated based on the y-axis of the set of points. Okay, now if this is the degenerative case, or the last case, or the end case, if P contains only 1 point, if P 1 point, if the set of points is only 1 point, so we are creating a leaf. Create leaf, let's call it leaf V, make J associated its associated structure, and that's it. Else, if it's not a leaf, let's split, and what will split? We'll split P to P left and to P right, again based on what is left or less or equal than, and what is higher than, but it will be based on what we will divide it is based on the x-axis, and less than or equal to what? So less than or equal to x mid, as we did 2x mid. This will be something that will be used to divide the points. If I have 1, 2, 3, 4, 5, I'll take the mid, and this one will be P left, and that one will be P right, and then that's how I will do that. And V left will get the Build2D range tree, namely recursive, and I will send P left and v right will be B2D range tree of p right. And now I will make the point that I divided using it. So I'll make v equal the x mid, v equal the mix in, and I will define v left child, let's call it LC left child, will be the v left, this one, and v right child will be v right, and the associated tree J associated will be associated to v, as we did here. It's associated to the x mid, as we did in the example. And in the end, after we finish all, so just return the root, which will be v. Okay, so the algorithm is set to do what I said. Take the set of points. Okay, it's not exactly by the how there, but take the mid based on the x. This is x mid. Put it right over here. Now take all your points. Those are the points. Okay, this is the p, and make the j associated based on the y-axis. Okay, so take these points and build in a binary search tree based on the y-axis. Okay, and you continue. Those will go to the left of it, and this will go to the right of it. And again, you do the same. You take the mid. We're building an associated j associated based on the y-axis of this point that are in the each set, p left, p right, and again you continue until you get to leaves and return the leaves. And let's say until you get to leaves. In the end, you will return the root of the two-dimensional tree. Okay, so this is the idea of the building of the 2D range tree. Thank you very much. If there are any mistakes or correction, please tell me. I wish it gave a little direction in understanding how to build a 2D range tree. Thank you very much. If there are any mistakes or correction, please tell me. And maybe something that I didn't talk about is the complexity of the of this 2D range tree. Maybe I need to talk a little bit about complexity. So let's talk about the complexity of this tree. So it has a query time. So it has a query time of O to the log 2n plus k, which is a little bit better than the KD tree query time, but we have increase in storage because compared to the KD tree, because the storage is O to the n, and maybe this is the range tree, and if you remember, for the KD tree, what we have there is query time of O to the square of n plus k, and storage of a little bit less, this is n log n, I forgot log, and this is O of n. Okay, so in the range tree it's a little bit more for storage. Query time can be better. So thank you very much. this was about the 2D range tree. If there are any mistakes or correction, please tell me. And what do I have left to say? Thank you very much.